Hey guys, I'm back with some more videos here, covering some more ACT style questions on the math section, uh, centering around the area, ideology of area. With that in mind, I'm going to make 3 videos that will discuss different versions of area questions that you will or could see on the ACT, and some of these may be applicable to the SAT as well. With that in mind, please remember to like and share and subscribe to the channel, because we're trying to make these videos to help young adults who don't have any access to help outside of school. Okay, let's get moving. First question. Okay. So this first question says, in the figure below, all segments that meet do so at right angles. What is the area in square units of the shaded region? So we just want that shaded region right there. And they just tell us that across the top, you have y2 and then y again. And then vertically, you have x, 2, and x. And then they tell you the length or the width, if you will, is 6. And then the other side of it is 5. How can we use this information here to figure out what these values for x and y are? Well, the first thing we can do, let me set up my pen, okay, is this. We know that this length of 5 will be related to the x variables. So we can say that 5 minus 2 leaves 3. Now, that's a distance of 3 that the x's have got to cover. So if we take 3 and divide it by 2, we're going to get, put a 0 there, 1.5. So the x values are equal to 1.5. Now, notice that each division for the y values is related to the length of 6. So each one of those are going to be 2 apiece, 2 for each y's. So the y's are going to be equal to 2. That was the easy one to figure out. Now, the area of the shaded box, the little box, it's just y by x, right? Well, you know the y is equal to 2, and we know the x is equal to 1.5. So the area is just 2 times 1.5. And 2 times 1.5 is 3. And that's going to give us answer choice G. All right, let's move to the next one. Now, this is a pretty neat question. It says, Kamini is constructing the kite shown below. The kite includes 2 perpendicular supports, one of the length of 40 inches and the other of 28 inches. The ends of the supports are connected with a string to form a 4-sided figure that is symmetric with respect to the longer support. It's a whole bunch of words that are really useless, but let's read them, continue. A layer of paper will cover the interior of the 4-sided figure. Now, that was an important sentence. Which of the following is closest to the area in square inches that Kamini will cover with paper? All right, so I'm going to change my pen tip. Well, before I do, we're looking for area, right? So notice there are triangles there. And, you know, most of the time when you're working the triangle, the area is always 1/2 base times height, right? So we need some information here. We can see, for instance, let me change to red. So the base here, we know is 28. So we got a big triangle here, And we got an even bigger triangle here. But they share a base that's 28. Now, they each have a certain height. So I'm going to call from here to here height 1. And then from here down to here, height 2. Okay, so we can use this information here. So let me change my pen tip. So we're going to say, I'm going to call the smaller of the two triangles H sub 1. And we know that's 1/2 base times height. Well, its base is 28. We'll call that height sub 1. And then we have A sub 2, which is the area for the triangle 2, the larger triangle, 1/2 base times height. And well, the base is the same shared between them. So 1/2 times 28 times H sub 2. Okay, now let's clean this up. 28 divided by 2 is a 14, and that leaves height sub 1. Well, the same thing here, but the difference is in the heights, right, of each of the triangles I outlined in red. Now, we can combine these two heights. Area total, combine these two heights, these two areas, sorry. So area 1 is 14 times H sub 1 plus area 2 is 14 H sub 2. Now, we can factor out the 14. And that's going to leave H sub 1 plus H sub 2. Now, we know both the heights, as shown in the figure, is equal to 40. Now we can multiply 40 times 14 and get 560. So our area total is 560, which is going to be answer choice C. All right, let's move on. All right, so if the length of a rectangle is increased by 25% and the width is decreased by 10%, the area in the resulting rectangle is larger than the area of the original rectangle. By what percentage? Okay, let's just assume, and I'm going to put it over here, let's assume that our smaller rectangle is 4 by 2. Now, if we take 25% of 4, so we're going to take 0.25 multiplied by 4, and we're going to get 100, right? Well, we got to move our decimal over 2 places, so we get 1. So the new rectangle length is going to be 5. All right. Now about the width. Now, and the width is decreased by 10%. So 10% of 2. So 2 times 0.1 is just going to be 2, but move your decimal over, you get 0.2. So it's decreasing by 0.2. So the width is going to be 1.8. Okay, so the area of the smaller rectangle is 8. So I'm going to put it in the middle of the figure. A is equal to 8. And then the bigger one is 9. Because that's 5 times 1.8 and 4 times 2. Now, we can finish the question. The area of the resulting rectangle is larger than the area of the original rectangle by what percent? So it's percent increase, percent decrease type of idea. With that being said, we're going to say 9 minus 8 over what we began with, 8, right? So that's going to be 1 over 8, 1/8. Or if you put that in decimal format, it's going to be 0.125 or 12.5%. And that's going to give us answer choice B as in boy. All right. Next one. Sometimes I know some of these seem real simple, but I'm putting them up there because these are the way area problems have occurred on the ACT. And I want you to have a good sampling of the questions so that there's nothing that you may be startled with on test day. All right, so in the figure shown below, all angles are right angles, and the side lengths are given in meters. What is the area in square meters of the figure? Well, okay, we can do a couple of things. There's a couple of ways to do this, but what I'm going to do it is, I'm going to do it like this. Let me get my red pen. Now I'm going to sketch in this top side, and I'm going to sketch in this piece here. So now we have a 10 by 8. So we know, let me change my pen tip. The area of a 10 by 8 rectangle, the big one right there, 10 by 8 is going to be 10 times 8, which is equal to 80. Now the little, portion we need to remove, right? So that portion is going to measure, let me change my pen tip. So we know the length of the side is 8, and we already see on the right side of 4, so we know this must be 4 here. Now we know the other length is 10, and we have 7 showing, so this piece must be 3. So that's a total of 12 for the area. Change my pen tip. So here we have a 3 by 4, or 4 times 3 is equal to 12. Now we want to subtract that piece out so we can get what's left over. So 80 minus 12 is 68. And so the answer is going to be H. Now, you know, you could have done it a different way as well, but sometimes it's just best to sketch the larger, enclose everything within one rectangle or with one square, and then pick it apart. But there's always more than one way to skin the cat. Okay, the next question. The diameter of a circle is 6 feet. Now, what color is my pen tip? Okay, it must be white. All right, cool. So the diameter of a circle is 6 feet. What is the area? So this one's easy. We got a circle. And we know maybe there's a center and the diameter is 6 feet. All right. What is the area of the circle in square feet? So the radius is 3. The radius is equal to 3. Now the area for the circle is just pi r squared. Pi 3 squared. Well, 3 squared is 9 pi. So the area of the circle is just 9 pi. And that's going to be answer choice H. I know that was an easy one, and most everybody will be able to do that. But again, please remember, I'm putting up all the different variations of how they've done area, tested area on the mathematics section of the ACT. I want you to have a good sampling. There's going to be 2 or possibly 3 more videos for area alone. So there are going to be more questions coming in a couple of more videos. All right, so here comes our last one. So a cube has a total surface area of 216 square centimeters. So we have a cube. Let me erase that. Okay. So we have a cube. Now I'm not a Picasso, but I'll try to draw it the best that I can. Back there, here, meet there. All right. So not bad cube. Now it has this total surface area of 216 square centimeters. Well, how many sides does a cube have on it? It has 6, right? Which of the following expressions gives the area in square centimeters of a single face of the cube? Well, there's 6 faces, right? So we take the total 216 divided by 6. And if you look at your answer choices, there, they don't have them calculated out to a single number. They just have it set up as a fraction. So it's going to be answer choice D as in dog. Okay, I'm keeping these categorized videos very short so they don't bore you. And there'll be 2, perhaps 3 more area videos coming at you, because that's how many different ways they have produced area questions on the ACT over many years. For all of you guys that are out there studying for the exam, I wish you all the best, and stay focused. Reach out for help when you need help. When you walk into the test on test day, don't just get it over with. Don't look back and get on with your life. All right. You guys have a great one.